بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 1.3 and it's about new functions from old functions. We studied functions in section 1.1 and 1.2, and now after we have seen these different kinds of functions in 1.2, uh, we will learn here how to even define more functions from the functions that we studied. So we do that by transformations, different transformations. First type of transformations would be translation. So uh, translating the graph of f. This is the graph of f of x in the middle. We can shift this graph or translate this graph to the right, to the left, up, or down. If the function is y equals f of x, then if you add c plus c, this means you will shift the graph of y equals f of x c units up. If you subtract c, remember that c is positive. So if it is plus 2, for example, 2 units up. If it is minus 2, 2 units down. If you subtract and add inside with x, not outside like here, so x minus 2, for example, would be 2 units to the right. Plus 2 would be 2 units to the left. Notice that plus minus with y will take you up and down, but plus minus with x will take you opposite side. In fact, all the translations will take you opposite side, but here, for this equation, it was y minus c, but we took c to the other side, and that's why there is a difference between y and x. So this what happens here, f of x minus c, so the graph is translated c units to the right and so on. The other type of transformations, we have stretching and shrinking, and we have reflection or reflecting. For stretching, we have vertical stretching and horizontal stretching. If you multiply outside by c, or 1 over c, this would be vertical stretching and shrinking. If you multiply inside or divide inside by c, this will mean horizontal stretching and shrinking. So with x horizontal, with y vertical. If c, notice that c is greater than 1. For example, 2, 3, 4, 1.5. If c is 1.5, 2, 3, then there will be vertical stretching like this. So this is the original function f of x. You stretch vertically, shrink vertically like this one, shrink vertically. While with x, if c is 2, then it's shrinking. So f of 2x will be horizontal shrinking. If it is half x, if it is less than 1, or you are dividing by c and it's greater than 1, then it's a horizontal stretching. So half x horizontal stretching, 2x horizontal shrinking, while 2y vertical stretching, half y vertical shrinking. Look to the graph of cosine x. The original cosine is with red. If you multiply outside by 2, this is vertical stretching. If you multiply by half, this is vertical shrinking. Now, look here again to cosine. It is with red. Now, if you multiply inside by 2, you will have horizontally shrinking. See, this was the period of cosine from here to here, and now the period is from here to here, because horizontally shrinking will shrink the period. While cosine half x, this would be horizontally stretching. So the period will be wider. See, it's not finished yet. The period would be up to here, the period of cosine half x. So that's the difference between vertical and horizontal stretching and shrinking. Reflecting, when you multiply by a negative sign. If you multiply by a negative sign outside y, you will reflect the graph about the x-axis. If you multiply inside x, you multiply x with negative, then you will shrink or you will reflect the graph about the y-axis. So multiplying x by negative, reflecting about y-axis, multiply y by negative, reflecting about x-axis. This is the original f. If you change x with negative x, then it's reflection about the y-axis. This is why you are reflecting this graph about the y-axis. Okay. While if you multiply outside by minus, then you will reflect this graph about the x-axis, about the x-axis. So this is the reflection. For example, here, what to do when you multiply by 2? You are multiplying each y by 2. Each y coordinates, you are multiplying it by 2. All right, this is an example. Given the graph of y equals square root of x, of course, square root of x has this graph. Use transformations to graph square root of x minus 2. So this is square root of x. What would be square root of x minus 2? It would be the same graph shifted 2 units down. So this would be the graph of square root of x minus 2. What about this one? Square root of x minus 2, but inside the square root. So this time the graph would be shifted. This graph would be shifted 2 units to the right. So this would be the graph of y equals square root of x minus 2. What about negative square root of x? Negative would be a reflection. Reflection about what? About the x-axis. So this is the x-axis. The graph is like this. You reflect the graph about the x-axis. So this is the graph of y equals negative square root of x. What about 2 square root of x? This is vertical stretching by 2. So 0, if you multiply 0 by 2, it is 0. But here at 1, it is 1. And now you multiply by 2, so it would be, instead of 1, it would be 2. And the graph would be like this. So this is the graph of y equals 2 square root of x. What about y equals square root of negative x? Uh, we know that anything inside the square root shouldn't be negative, it should be positive. So for this, negative x is positive, so x is negative. Anyway, negative multiplied by x means a reflection about the y-axis. So this was the original function, and you reflect the graph about the y-axis. So this would be the graph of y equals negative x. You notice that x is negative. So negative x would be positive and everything would be fine. So the domain of this function is from negative infinity to 0. All right. The second way to obtain new functions from old functions is by combining the two functions, by finding the sum, the difference, the product, the division, the quotient of two functions. Okay, so that's it. How to define the sum? Very simple. F plus g of x would be f of x plus g of x. Also the subtraction, also the multiplication, and the division. Now, a question. So, for example, uh, if f of x is square root of x and g of x is square root of 2 minus x, what would be f plus g of x? It would be f of x plus g of x, so it would be square root of x plus square root of 2 minus x. All right? If it is minus, you will have a minus here. If it is multiplication, you will multiply this times this. If it is division, you will divide. For example, if f of x is x squared and g of x is x minus 1, then f over g would be x squared over x minus 1, would be f of x over g of x. And now the question is, what would be the domain of these new functions? Well, it is related to the domain of f and g because we obtained f plus g from f and g. So the domain of f plus g and f minus g and f times g, okay, f times g, all of these three, their domain is a intersection b, a intersection b. Okay, why? Because to find f plus g of x, I need to use f of x and g of x. So I need the domain of f and the domain of g. So the intersection. So for example, here in this question, in this example, f of x square root of x, g of x square root of 2 minus x. To find the domain of f plus g, I need to find the domain of f. Well, this is a square root. X has to be positive, so the domain is from 0 to infinity. Also, g is a square root, so 2 minus x has to be positive. So 2 minus x is positive, which means 2 is greater than or equal to x, or x is less than or equal to 2. So it's from negative infinity to 2. Now, what would be the domain of f plus g? It would be the intersection between these two. Okay, how to find the intersection? I have 0 and 2. The domain of f is from 0 to infinity. The domain of g is from negative infinity to 2. So where is the intersection? It is between 0 and 2. So this would be the domain of f plus g, f minus g, and f times g. But f over g, well, the domain would be the intersection, but you have to take from the intersection the zeros of g because g is in the denominator now, and we cannot accept that it is zero. So it would be the intersection, but g of x is not zero. So for example, here the domain of f plus g would be, domain would be 0, 2, similar to this, but we have to remove the zeros of g. Where is g? This is g. What makes g 0? The 2. So the domain of f plus g in this question would be from 0 to 2 open. Okay? Because 2 is not accepted now. It's not in the domain of f over g. Another example, f equals x squared. What is the domain of f? All real numbers. G equals x minus 1. What is the domain? All real numbers, because no root, no denominator. So the domain of f plus g, f minus g, f times g in this case would be all real numbers. But the domain of f over g would be all real numbers except the 0 of g. What is the 0 of g? 1. So the domain of f over g would be all real numbers except 1. So it's from negative infinity to 1, union from 1 to infinity. All real numbers except 1. Another way to find new functions from old is to use the operation composition, okay, to find the composite function between two functions. If you have f and g, you can find f circle g of x, and the definition is f of g of x. So that's the definition of f circle g, or the composition. So for example, if f of x is x squared and g of x is square root of x plus 1, then f circle g of x would be f of g of x would be f of, and now you put g of x inside f, and now you find f of this. How do you find f of anything? That's the definition of f. So I should replace x by square root of x plus 1. So it would be square root of x plus 1 raised to the power 2, and 2 cancels the square root, and the answer would be x plus 1. Now what would be the domain of f circle g? Well, it would be the domain of the answer, the result, intersection the domain of g, because first you find g of x. So set of all x in the domain of g, domain of g is important, such that g of x is in the domain of f. So g of x should be in the domain of f. Or I can just say easily that the domain of f circle g is the domain of g intersection the domain of the result. What do I mean by the result? This one. So in this example, what would be the domain of f circle g? What is the domain of g here? What is the domain of g? G is a square root, so x plus 1 should be positive. So x should be greater than or equal to negative 1. So the domain of g would be from negative 1 to infinity. This is the result. What is the domain of the result? Everything, or real numbers, because it's a straight line, no rational, no denominator, and no root, no square root. So what would be the intersection? It would be the intersection between this, and the intersection is from negative 1 to infinity because this is all real numbers. This is a shape figure will help you. Okay. Uh, the if circle G, what happens? This is the input, this is the output. What happens? If X is the input, it goes first to G, not to F, to G first, because the definition says what? F of G. So X goes first in G. So the input goes in G, then the output would be G of X, and then G of X will go inside F, would be the input inside F, and the outside output would be F of G of X. So X will come inside F circle G, and it would be F of G of X. Some examples. Let us find here F circle G of X. By definition, it is F of G of X. So it is F of, put G of X inside, replace G of X by its definition, and then find F of X minus 3 from the definition of F. So replace X by X minus 3. So it would be X minus 3 to the power 2. While G circle F of X would be G of F of X. It would be G of, put F of X, put the definition, it's X squared, and then find G of X squared. How? Go to G and replace X by X squared. So it would be X squared minus 3. Another example, this is F and this is G. Find each function and its domain. Okay, so let us find F circle G of X. It would be F of G of X. It would be F of, what is G of X? Square root of 2 minus X. And then what is F of square root? It would replace X by the square root, but I have already square root, so it would be square root of, and replace this X by the square root. When you have two square roots like this, you multiply the indices. 2 times 2 would be 4, and you will have the fourth root of 2 minus X. To find the domain of F circle G, I need the domain of G and the domain of the result. This is G. 2 minus X should be greater than 0 or equal. So 2 should be greater than or equal to X, or X is less than or equal to 2. So the domain of G is from negative infinity to 2. What is the domain of the result? This is the result. The domain of the fourth root is exactly the same as the domain of the second root, square root. 2 minus X should be positive. So it will give you the same domain. Okay, so it's again from negative infinity to 2. Their intersection would be the same. So the domain of F circle G is from negative infinity to 2 and closed from 2. All right, let us find G circle F. G circle F of X is G of F of X, and it is G of square root of X, because F of X is square root of X. And now we find G of square root of X. How? We replace X in the definition of G by square root of X. Well, I have square root of 2 minus and replace X by square root of X. So this is the result. Now, the domain of G circle F is the domain of F intersection the domain of the result. What is the domain of F? F is square root of X. So x should be positive, and the domain is from 0 to infinity. Now, what is the domain of the result? This is the result. I have two square roots. Here, x should be greater than 0 or equal to 0. So this is one condition. And 2 minus square root of x should be also greater than or equal to 0. So 2 should be greater than or equal to square root of x. Squaring both sides, because both are positive, so you can square both sides. So x is less than or equal to 4. So x should be greater than or equal to 0 and less than or equal to 4. So it's greater than or equal to 0 and less than or equal to 4. So it's between 0 and 4. So the domain of the result is 0 and 4. If you replace x by any number here, this will be evaluated. But if you 5, for example, if you replace x by 5, then 2 minus square root of 5 is negative number. Math error. It cannot be evaluated. It's not real number. Now, what is the definition, the domain of G circle F? It would be their intersection. What is the intersection between 0 to infinity and 0 to 4? Just 0 to 4. So this would be the domain of G circle F. Now, what about F circle F? Well, F circle F of X is defined similarly. It would be F of X. What is f of x? It's the square root of x. And now what is f of square root of x? You replace x by square root of x. So I have a square root of x, but this x will be replaced by square root of x. I have two square roots, multiply 2 times 2, so it's the fourth root of x. Now what is the domain of f circle f? Okay, it would be the domain of f intersection the domain of the result. We have seen that the domain of f is from 0 to infinity. The domain of the result here is also from 0 to infinity because the fourth root is similar to the square root. So the domain would be from 0 to infinity. Finally, G circle G of x. It would be G of x. It would be G of. What is G of x? It's the square root of 2 minus x. And what would be G of this? It would be square root of 2 minus, and I replace x here by the square root of 2 minus x. So this would be G circle G of x. What would be the domain of G circle G? The domain of G, as we have seen here, is from negative infinity to 2. And now I need to find the domain of the result. Look to the result. I have two conditions. 2 minus x should be greater than 0. So 2 is greater than or equal to x, or x is less than or equal to 2. This is the first condition. Another condition, 2 minus square root of 2 minus x should be also positive. Okay, so 2 should be greater than or equal to this square root. Both are positive, so I can square both sides. Take x to this side and take 4 to that side. So x is greater than or equal to negative 2. So x is greater than or equal to negative 2, and it is less than or equal to 2. So x is between negative 2 and 2. So the domain of the result is from negative 2 to 2. Now, what is the intersection between these two? It is from negative 2 to 2, and this would be the domain of G circle G. Finally, we can find the composition of three functions. So f circle G circle H of X would be f of G of H of X. So first we write H of X. What is H of X? X plus 3. And now I find G of this. So this is f of. How to find G of this? I need the definition of G. This is the definition of G. It's x to the power 10. So I replace x by x plus 3. So it's x plus 3 to the power 10. And now I need to find f of this. How? I go to f, this is f, and I replace x by x plus 3 to the power 10. So I have x, I replace it by x plus 3 to the power 10 over. I have x plus 1. So again, I replace x by x plus 3 to the power 10 and plus 1. That's the end of this lecture. Enjoy your time and your study.